My name is Jack Gore. The topic of our project is Bohr radius, which is a fundamental physical constant representing the most probable distance between the electron and the nucleus in a hydrogen atom in its ground state. The relevant fields in Bohr radius include atomic physics, which is the scientific study of the structure of an atom, its energy states, and its interactions with other particles and with electric and magnetic fields. It also includes quantum physics, which explains the behavior of matter and the light at the atomic and subatomic levels. The creator of Bohr radius is Niels Bohr. He was born in Copenhagen, Denmark on October 7, 1885. He was a Danish physicist who made a foundational contribution to understanding atomic structure and quantum theory. He was also a philosopher and a promoter of scientific research. He developed the Bohr model of atomic structure in 1913. The original gathering of Bohr radius relied on the principle of quantized angular momentum and classical physics. Bohr suggested that electrons orbit the nucleus. He then equated the centripetal force keeping the electron in nucleus by applying the quantization condition for angular momentum. Bohr was able to come up with the formula for the radius of these orbits. One of Bohr's complications was the inability to accurately describe the behavior with more than one atom. It does not work with multiple electron atoms. Bohr's objective was to quantize the atom by addressing the issue. He was motivated to find a method of classical dynamics methodology to address a non-classical quantum problem. He also proposed a model to explain the shift in spectra of a hydrogen atom. The quantization of the angular momentum was obtained. The benefits are that the balance of an atom is that the electron energy is steady and in orbit. It gives a foundation for determining the energy of electrons in a specific orbit as well as the radius of an orbit from which they spin around a nucleus that is positively charged. The model presents the main quantum number, which indicates the orbit's energy. Bohr's model was provided incorrect but is still used in some way. We now measure the wavelengths of light emitted or absorbed by hydrogen atoms, and we then compare them to wavelengths predicted by Bohr's model. The difference in the modern approach is that electrons exist in electron clouds around the nucleus, and Bohr's approach was the electrons orbit the nucleus in fixed paths. The modern benefits of Bohr radius is the understanding of atomic structure. Helping explain spectral lines, it provides a basis for quantum mechanics. It is a useful reference point for calculations and helps people understand the behavior of electrons and atoms. Future expectations of Bohr radius include quantum testing, scientific standard, and continued education. The question I chose is, what does Bohr radius represent in an atom, and what is the approximate value? This question is relevant to Bohr radius because the Bohr radius is tied to Bohr's model of the atom. It also tells us the size of the hydrogen atom. Without Bohr radius, we would not have physical size to describe atoms in early quantum theory. The benefits of understanding this question are: it tells us how big atoms are. It helps us predict how electrons behave in atoms. It tells us the distance between the proton and the electron in a hydrogen atom when the electron is in its lowest level. It provides a foundation for understanding chemical reaction and atomic structure. A person gains a deeper understanding of how atoms are structured and critical thinking about how the universe works at a microscopic level by solving this question. The question: what does Bohr radius represent in an atom, and what is its approximate value? It's not too simple, but also not too complicated to be useful. It's not too simple because you have to understand basic atomic structure, electron energy levels, and quantum theory. It's not too complicated because it focuses on a single single clear idea without bringing in complicated math. I decided against using this question, how is Bohr radius defined, because it was too simple and just asked for a definition. I wanted the question to have more critical thinking. The question is unique because it combines measurement meaning and major scientific history into one question. It also connects atomic structure with quantum physics. The question makes you understand what Bohr radius means and just not the number of it. There is only one relevant formula for Bohr radius, and this formula will give you the distance between the nucleus and the electron. The solving process for Bohr's radius is: first you square the reduced Planck's constant, second square the elementary charge, third multiply the numerator, fourth multiply the denominator, last step divide the two results. The answer should be A0 equals 5.29 times 10 to the negative 11 meters. Some more valuable information on Bohr's radius is that Bohr's work contributed to semiconductor physics and the development of quantum theory. We were interested in how something as small and invisible as an electron's orbit could be defined so precisely, and how the small distance changed our entire understanding of the atoms. The Bohr radius is a fundamental constant that represents the most probable distance between the proton and the electron in the hydrogen atom. It marked a revolutionary step in atomic theory when introduced by Niels Bohr in 1913. His model, through the later refined, gave rise to modern quantum mechanics. Today, the Bohr radius still plays a key role in atomic calculation and remains the building block of physical science education.